Hello everyone, welcome back to our YouTube channel Oilfield Inside TV. Today we will be showing video for oil and gas formation and drilling process. Introduction. Crude oil and natural gas. Where exactly do they come from? Well, the process took place millions of years where remains of plants and animals and microorganisms that once lived long ago, way before the dinosaurs. Fossil fuels. These roughly are fossiliferous, meaning dug up. Crude oil and natural gas are made from biotic material, which means basically remains of tiny marine plants and animals that once lived millions and millions of years ago in an aquatic environment. Through years, these plants and animals died and were carried by layers of sediments, sand, and water. Microorganisms fed upon decomposed organic material in a process called biogenesis. More layers of sediments eventually build up and buried remains deeper and deeper within the earth. This enormous pressure from these layers combined beneath the earth crust essentially cooked the biotic material. Oil and gas formation. Oil is a mixture of liquid hydrocarbons that are formed in sedimentary rocks along with gaseous and solid hydrocarbons. That is to say, gases or by two as well as other substances. All the molecules of hydrocarbons are made up of two atoms, carbon and hydrogen. It is the only quantity of carbon molecules that determine the fate of hydrocarbon gases, up to 4 atoms, liquids from 5 to 16 and solid more than 16. Hydrocarbons are non-renewable energy sources and are formed over a long period of time. The most favorable location for the formation of hydrocarbon are the places like seabed characterized by which contains flow of detritus materials from river. Over millions of years, the accumulated rock, sand and clay mixed with animal and vegetable organisms and microorganisms are compacted, forming the basis of sedimentary rock. The organic substances trapped in the rock, so-called mother rock, are transformed under pressure at certain depths and higher temperature. First is the corrosion and then hydrocarbons. The whole process takes between 10 and 200 million years. Hydrocarbons that are lighter than water tends to rise up and spread laterally through permeable rock. In some places they rise to the surface and disposed. In others, they rise block by block or layer of impermeable rock in the shape of a dome that transforms. Exploration. The search for new oil field is very expensive. Consequently, it must be carried out by great care. First of all, a map of surface rock is put together by analysis of aerial and satellite photographs. And with the help of geochemical, micropaleontological, and petrographic techniques, a picture is created of the physical, chemical composition, and age of the rock. When an area seems to be interesting, has been identified, geophysical methods such as or known as seismic reflex is used to locate the reservoir. This technique involves the creation of underground seismic waves generated by small scale explosions or vibrating devices, while in the sea by the rapid expansion of compressed air. These seismic waves are generated at depths through layers of rocks and reflected differentially according to the density of the rock. When these return to the surface, the intensity of the waves is measured and computers are used to process and interpret the data together. Not only underground traps contain oil, it is only determined by drilling an exploratory well. to hold the pieces of equipment and pipe during drilling process. It's then time is to bring in rig equipment and rig up a rig that can drill 10,000 feet of a well. Requires 50 to 75 people and 35 to 95 semi-truck to move and assemble a rig normally 3.5 days. The rig is then inspected to make sure all specification and safety standards. Rig operation continues 24/7, 7 days a week, closing only one day for Christmas. Two shifts of complete drilling crews are assigned for the entire drilling project. Drilling happens in stages, drilling, running in casing, cementing and then drilling again until the bit reaches TD or zone. True depth is achieved or reached. A bit generally lasts for 4500 to 6500 feet of a drilling. Replacing a bit requires removal of entire drill string pipe called trip out or pull out. It is a process that can take several hours. Before this is done, the BOP or blowout preventer is then installed on the top of the casing hand before drilling commences. It contains high pressure safety valves designed to seal the well hole and block underground gases or fluids in order to prevent blowout from occurring. Now the drilling begins with a designated hole of a depth. Before this is done, derrick hand line up mud pump and starts mud pump to circulate the hole and cool the bit and brings cutting to the surface and keeps the well of hole intact. To help keep cuttings plugging the hole, this mud passes through shaker that separates the cuttings and bring it to the bit to drill ahead. Additional mud system equipment, degassers and desilters. Degassers remove small portions, particles and gas from the mud. The clean mud then circulates back down into the hole. Drilling a hole of a designated surface depth, usually about 50 to 100 feet below the water table. Special care is taken to prevent contamination of the groundwater by isolating the water table from the well by cement and steel casing. The bit is the cutting element used in the rotary drilling. As the bit turns, it crushes the rock efficiently and shoots fluids out to carry rock chip cuttings to the surface. New sections of pipes are added to the drill string. As the bit drills deeper, the hole reaches designated depth. The derrick hand circulates drilling fluid to cool the bit and brings cutting to the surface for the next operations. The well is initially drilled to a designated distance below the deepest freshwater source near the surface. The pipe and bit are then removed and surface casing is inserted in the hole. The casing is secured into place by pumping cement through the casing and through the shoe at the bottom of the hole. The cement barrier and the casing prevent contamination of the freshwater aquifers. Once the casing cement has set, drilling of the intermediate section of the hole continues by drilling through the wiper plug, shoe and cement at the bottom of the well bore and onto the targeted zone. Throughout the drilling, a mixture called mud is pumped down into the well through the drill pipe. The mud serves to keep the bit cool. It carries the cuttings to the surface and provides hydrostatic pressure inhibiting formation fluid from entering the well bore. Now, the drilling approaches the depth of the target zone.
Directional drilling. Directional drilling is the practice of accessing an underground oil and gas reserves by drilling in a non-vertical direction. It is also called directional boring. Directional drilling increases the efficiency of oil and gas extraction and can also lessen the environmental impact of drilling. Directional drilling includes three main specialized applications: ERD, extended reach drilling, multilateral drilling, and short radius drilling. Operators have used ERD to access offshore reservoirs from land location, sometimes eliminating the need for a platform. Steps involved in directional drilling. The first stage consists of a directional drilling a small diameter pilot hole along a designated directional path. The second stage involves enlarging this pilot hole to a diameter suitable for installation of the pipeline. Third stage consists of pulling the pipe back into the enlarged hole. Coring. Coring is a method of collecting rock and sediment samples for geological research. A coring drill bit is designed with a central opening around which the drill bit cuts the borehole. Functions. Through core drilling, teams can learn the density, chemical composition, strength and other properties of the specific materials. The reason it's important to use a hollow drill is that the purpose of core drilling is to extract a sample from the surface. The extracted sample is then brought to a lab for further testing. Tools used in coring: concrete core drill bits, diamond coring bits, masonry saws, and core retrieval tongs are used.
Well logging is the process of measuring and recording characteristic of well. The logging information lets the oil company to determine if the well indeed can produce oil or gas. At this point, the company will decide whether the well is to be completed or plugged and abandoned. If the well is designated as a producer, the crew inserts the pipe back into the hole to ensure that the hole is still intact and circulates mud fluid. Porosity tool, which can counter how many hydrogen atoms in the surrounding rock, can be seen in this section of a log. A higher concentration of hydrogen in the rock indicates the possible presence of oil. When the curve moves to the right, this indicates the fewer hydrocarbon atoms. So as we move down the well bore, we can see that the amount of hydrogen is generally decreasing. This means either there is very tight rock that cannot hold the oil or gas may be present. Working in tandem with neutron porosity tool is the density porosity tool. It measures the space between the electrons in the rock, also known as the bulk density. Near the top of the rock, the greater amount of density, but as we move down the wellbore, log indicates the rock is becoming less dense. You will notice that in this section the density porosity curve and the neutron porosity curve cross over. This is the significant. Whereas the neutron curve indicates either tight rock or gas, the density porosity curve tells us the rock is more porous and therefore cannot be a tight rock. This indicates the high probability of oil and gas formations. Mud logging. Mud logging is a real-time well site evaluation technique. It involves lag time determination, rock cutting descriptions, gas detection and analysis, and hydrocarbon detection. A mud logger is brought on location. He analyzes rock cuttings, identifies downhole lithologies, and any presence of hydrocarbon as the well is being drilled. Once the bottom of the intermediate section is reached, the drill pipe and bit are again removed from wellbore. An intermediate casing is inserted in the hole and connected to the surface casing. The intermediate casing is also cemented to secure the hole. The drill pipe and bit are again lowered back into the hole and drills through wiper plug and cement. Once TD is reached, drill pipe and bit are removed from hole one last time. Next, a logging tool is lowered on a wire line. As the tool is pulled back, data is gathered to create an electric log. Once the well is logged, being the commercial well, production casing is then inserted. As with the surface and intermediate casing, the production casing is also cemented in place. casing is also cemented in place into the hole. Back on the surface, the drilling rig is no longer needed. A temporary wellhead is installed and the location is prepared for the service crews who is already there for a production job. The first step is to perforate the casing. A perforating gun is lowered by wire line to the lowest of three targeted zones. An electrical current is sent down the wire line into the perforating gun, setting off a charge which shoots hole through steel casing, cement and out of the short distance into the target formations. The perforated gun is then pulled out of the hole. The next step is to hydraulically fracture the zone. Here, sand or proppants are pumped into the wellbore under extremely high pressure. When the mixture reaches the targeted zone, the presence of pressure forces out to the perforated holes and to the sandstone formation, causing it to fracture. This creates a fairway connecting the reservoir to the well and allow the released oil to flow to the wellbore. Next, a bridge plug is placed inside the production casing, isolating the fracture zone. The hydraulic fracture is then repeated for zone 2 and 3. Now that the fracture process is complete, the plugs are drilled out and production tubing is lowered into wellbore to reach each of the productive zone. Hydrocarbons are then flow simultaneously from each of the zone to the well. The next step is to install permanent wellhead and other necessary surface equipments. Sometimes a pump jack or a SRP called sucker rod pump is used to help bring the oil to the surface.
discoveries around the world. This moving monument in the sea has been a product of technological innovation and evolution from a fixed marine platform to a moving drilling vessel and finally to its present form of three-legged movable structure, providing utmost safety, efficiency, and most economic drilling at oil well deep beneath the sea. The drilling can be in the open sea for exploratory wells and fixed platform for production wells. Today, ONGC owns a large fleet of offshore rigs including Sagar Samrat, Sagar Pragati, Sagar Gaurav, Sagar Shakti, Sagar Jyoti, Sagar Ratna, Sagar Kiran, and Sagar Uday, and several chartered hire rigs. ONGC also has drill ships like Sagar Bhushan and Sagar Vijay. A jack-up rig typically has a triangular structure and stands over three legs. These legs can be jacked up and down with the help of series of jacking units. The body of the rig called hull has two major sections. One side is the accommodation area, which also houses radio room, control room and offices. The accommodation room offers comfortable stay for the people. The kitchen, also known as the galley, works round the clock preparing delicacies favorite for the men at work. A spirit of teamwork in a family environment is created in the dining hall and the recreation rooms. The other side is equipped with rigs substructures on which is mounted the drilling mast and drive systems. Material handling cranes are mounted at the top of all the three sides of the rig. At the bottom is the machinery deck equipped with power generators, water making plant, storeroom, and utility room. An oil well blowout is an uncontrolled influx of formation fluid, salt water including crude oil. It occurs when pressure release system fails. This is also called as a kick, which displaces considerable amount of drilling fluid. They can also occur if a spark or flame contacts the oil or for the other reasons. Oil well blowouts cause death and catastrophic injuries to workers near the scene of a blowout. Causes: an oil rig blowout can occur when a rig applies excessive pressure during the drilling, forcing the underground pool of oil to erupt. Using unsafe drilling practices and defective equipment can hasten the blowout, exposing workers to multiple risks. Prevention: how do you prevent oil well blowout? The answer is maintain your BOP equipment. Other BOP maintenance practices to promote oil well safety include remove all the metal fragments in the BOP using a downhole magnet, clean out the mud in the equipment to minimize the risk of leakages, grease all moving parts in the BOP equipments, and last but not the least, close monitoring of all the drilling and completion activities with utmost care.